Understanding glaciers. Formation and nature. Glaciers are vast, slow-moving rivers of ice. They are not just frozen water, they are powerful forces that shape our planet. These immense bodies of dense ice are found on land and persist for many years, sometimes centuries or millennia. Glaciers form in areas where more snow falls than melts, typically in polar regions or high mountains. The process of glacier formation is slow and steady, requiring specific cold climatic conditions to begin. Year after year, snow accumulates in these frigid zones. The journey from a delicate snowflake to solid glacial ice is long. It begins with layers upon layers of snowfall that build up over considerable time. The weight of the overlying snow exerts immense pressure, compacting the snow crystals below. Air is squeezed out from between the snow grains, and the snowflakes gradually lose their original intricate shapes, becoming more rounded and granular over time. This transformation is a crucial step in ice development. The snow slowly begins its metamorphosis into something much denser, known as firn. Firn is an intermediate stage between snow and glacier ice, left over from past seasons and recrystallized into a denser substance. As more snow accumulates on top, the firn is buried deeper, and the pressure continues to increase significantly. This immense pressure causes the firn to compress further, with air pockets becoming smaller and more isolated. Eventually, the firn transforms into solid, dense glacial ice, often characterized by its bluish tint. The entire process of glacier formation is a testament to time, demonstrating the power of sustained environmental conditions. Hundreds or even thousands of years might pass before enough ice accumulates for a true glacier to begin to form. Glaciers are therefore ancient features of our Earth, holding within them records of past climates. Their very existence depends on a delicate balance between snowfall and summer melt, year after year. These icy titans are more than just frozen landscapes. Scientists generally classify glaciers into two main types: alpine glaciers and continental glaciers. Alpine glaciers are found in high mountain ranges and are also known as mountain glaciers or valley glaciers. These glaciers carve out U-shaped valleys as they flow. Cirque glaciers are smaller, forming in bowl-shaped depressions. Alpine glaciers are constrained by the topography around them, often resembling rivers of ice flowing down slopes. Their size can vary greatly, from small patches to vast systems. Many famous mountain landscapes are shaped by these glaciers. Continental glaciers, on the other hand, are much larger in scale. They are vast sheets of ice that cover entire land masses. Ice sheets are the largest type of continental glacier. Greenland and Antarctica are covered by massive ice sheets. Ice caps are smaller versions covering less than 50,000 square kilometers. These glaciers are not confined by topography, but spread outwards from a central thick point. Their immense weight can depress the Earth's crust beneath them. Continental glaciers hold the majority of Earth's fresh water, and their stability is crucial for global sea levels. The primary cause of current glacier melting is global warming. Human activities have significantly increased greenhouse gases, which trap heat in the Earth's atmosphere, leading to a gradual rise in global temperatures. This phenomenon is often referred to as climate change. Even small increases in average temperature have big effects. Glaciers are extremely sensitive to these temperature changes. Warmer air temperatures accelerate the rate of surface melt, and warmer ocean waters can also melt glaciers from below, especially those that terminate in the sea. The albedo effect also plays a significant role. Albedo refers to the reflectivity of a surface. Fresh snow and ice have a high albedo, meaning they reflect a lot of sunlight back into space, helping to keep the glacier and surrounding areas cool. However, as glaciers melt, darker surfaces are exposed, such as rock, soil, or meltwater ponds. These darker surfaces absorb more sunlight rather than reflecting it, leading to further warming and more melting. This creates a positive feedback loop, accelerating ice loss. The evidence for widespread glacier melting is undeniable. Recent statistics paint a concerning picture of rapid loss. Around the world, glaciers are retreating at alarming rates. Studies show that the vast majority of glaciers are shrinking. For example, the World Glacier Monitoring Service reports consistent negative mass balances, meaning more ice is being lost than gained each year. Satellite imagery from recent decades clearly shows this retreat. Many glaciers have lost a significant portion of their volume, and some smaller glaciers have disappeared entirely. This trend has accelerated significantly in the 21st century. One of the most significant impacts of glacier melting is rising sea levels. As land-based ice melts, the water flows into the oceans, adding to the total volume of water in the sea. Ice sheets in Greenland and Antarctica are major contributors, with their meltwater alone capable of raising sea levels by many meters. Even the melting of smaller mountain glaciers adds up. Rising sea levels threaten coastal communities worldwide, leading to increased coastal erosion and flooding. Low-lying islands and nations face existential threats, and this displacement of people creates further global challenges. Glacier melt also puts immense strain on freshwater resources. Many communities rely on seasonal glacier melt for their water, which is crucial for drinking, agriculture, and industry. In regions like the Himalayas and the Andes, this is vital. Billions of people depend on rivers fed by glacial meltwater. As glaciers shrink, the summer meltwater supply diminishes. Initially, melting might increase water flow, causing floods, but eventually, the water source will dwindle significantly, leading to water scarcity and potential conflict. Ecosystems that depend on this regular water supply also suffer. The largest glacier in the world is the Lambert Glacier, located in East Antarctica, a vast icy continent. This colossal river of ice flows from the Antarctic ice sheet, draining a significant portion of the East Antarctic ice sheet. The Lambert Glacier is about 100 kilometers wide, over 400 kilometers long, and about 2,500 meters deep. Its sheer scale is difficult to comprehend fully. Even this giant is not immune to the effects of warming. Scientists monitor it closely for signs of change, as changes in the Lambert Glacier could have global implications. The continued melting of glaciers poses a severe threat. It is a clear indicator of a rapidly changing planet. The consequences extend far beyond icy landscapes, affecting global weather patterns, ecosystems, and human societies. We are witnessing a fundamental shift in Earth's cryosphere. The loss of these melting giants is not a distant problem. It is happening now, and its impacts are already being felt. The future stability of our environment is at stake. Ignoring this crisis is no longer a viable option. The time for decisive and collective action has arrived. Addressing glacier melt requires robust mitigation strategies. The primary goal must be to reduce greenhouse gas emissions. This involves transitioning away from fossil fuels and embracing renewable energy sources like solar and wind. Improving energy efficiency in all sectors is crucial. Protecting and restoring forests can help absorb carbon dioxide. International agreements and national policies are essential, setting ambitious targets for emission reductions. Every individual action also contributes to the larger effort. Reducing our carbon footprint is a shared responsibility. Alongside mitigation, adaptation strategies are also necessary. Some degree of future warming and glacier melt is unavoidable. Communities must prepare for the impacts of these changes, developing plans for rising sea levels. Coastal defenses and relocating vulnerable populations may be needed. Water management systems must adapt to changing river flows, investing in water conservation and alternative water sources. Developing drought-resistant crops can help agriculture. Early warning systems for glacial lake outburst floods are vital. Adaptation helps build resilience in the face of change. The challenge of glacier melt is immense, but not insurmountable. It requires a global commitment to sustainability. We must protect these critical components of our planet. Future generations depend on the choices we make today. By understanding the science and acknowledging the risks, we can work together to slow down this alarming trend. Let us strive for a future where these icy giants can endure. The health of our glaciers reflects the health of our Earth. It is our collective duty to preserve them. The time to act decisively is now before it's too late.